This problem, we are using half angle identities to find the sine, cosine, and tangent of an angle. We don't know what the angle is, but we do know what cosine of the angle is. Now, resist the temptation to do cosine inverse or inverse trig function to find x. So what we're going to work on is, if you do that, by the way, you're not going to get the exact value unless you have the right kind of calculator, and then it might look really funky. But I'll just show you how to do it. It's not that bad. Now, these are the formulas from the book. So sine of the angle over 2 is plus or minus 1 minus cosine alpha over 2. The plus or minus depends on which quadrant you're in. And cosine of alpha over 2 is plus or minus square root of 1 plus cosine alpha over 2. And tangent of alpha over 2 is plus or minus square root of 1 minus cosine alpha over 1 plus cosine alpha. Now you could also do sine of alpha over 1 plus cosine alpha, or 1 minus cosine alpha over sine alpha. But what I want to point out is they give us the cosine, which is what each of these uses. So we don't really, if I can use that, and then this one here, and I don't need to find the sine. But if you did want to find the sine of the angle, so just draw yourself a little triangle, not to scale. So if this is my x, cosine is adjacent, so 3 over hypotenuse is 5. I'm going to call this b. And then 3 squared plus b squared equals 5 squared. So 9 plus b squared equals 25. So b squared is 16. So b is 4. So if you knew up front that that was a 3, 4, 5 triangle, good job. So that means that sine of x would be 4/5. So we could just run down here and take care of the tangent one, use one of these 3 things. Like I mean, it really doesn't matter, but it might be easiest to use the bottom one. So 1 minus cosine of x over sine of x. So that's going to be 1 minus 3/5 over 4/5. So that's 2/5 over 4/5, or 2/5 times 5 over 4. And the 5's divide out. I'm going to change colors. 5's divide out leaves us 2/4 or 1/2. Okay, so I really couldn't help myself. I had to go do that one. So let's do the ones that are a little more complicated because they have the plus and minus in there. So here we go. Sine of x over 2 is going to be the square root plus or minus the square root of, and it says it's in quadrant 1, so half of something in quadrant 1 is still in quadrant 1. So I can just drop the plus or minus because it's going to be positive. So we have 1 minus 3/5 over 2. So that's going to be the square root of, so 1 minus 3/5, it's 5/5 minus 3/5 is 2/5 over 2. Let me shorten this a little bit for more space. So that's going to be the square root of 2/5 times 1/2. So multiplying by the reciprocal of the denominator. Those divide out. So I have the square root of 1/5. So think of that as 1 over the square root of 5. So if I have 1 over the square root of 5, or multiply by the square root of 5 over square root of 5, to rationalize the denominator, not have a radical down below, that's where we get the square root of 5 over 5. Now in the second one, it's very similar, but square root of, and again it's going to be positive because it's first quadrant, because half of something in first quadrant is still in first quadrant. Here we have 1 plus the 3/5 over 2, and again I made that square root symbol too large. So that's going to be 5/5 plus 3/5 is 8/5, so 8/5 over 2. So we have the square root of 8 over 5 times 1/2. Then we can reduce out 2 with the 8, leaves a 4 up here. So we have the square root of 4/5 is 2 over the square root of 5. We rationalize the denominator, and we get 2 root 5 over 5. So that's where this comes from, 2 root 5 over 5. We already found the tangent. Now again, you could have used just the cosine to find the tangent. So like, let's just say if we did that, tangent of x over 2 would have been the square root of 1 minus 3/5 over 1 plus 3/5 would have been the square root of 2/5 over 4/5. No, it was 8/5. Excuse me. Erase, please. So that'd be the square root of 2 over 5 times 5 over 8 equals the square root of 1 over 4, which is 1/2. So that's the second way to get the same thing. Okay, hope that helps. Let me know if you still have questions.